For more than 100 years, diesel ran the world. Every truck that ever hauled coal, steel, food, or furniture started with the same loud black smoke belching engine under the hood. If it moved on wheels and it moved something heavy, it almost certainly ran on diesel. But right now in China, something happened that logistics experts said could not happen for at least another decade. In December of 2025, electric trucks outsold diesel trucks in China for the very first time ever. Not electric cars, trucks. The big, heavy cargo hauling machines that keep entire economies running. 54% of new heavy-duty truck sales that month were electric. There are now more than 500,000 electric heavy trucks already working on Chinese roads today. This sounds like it should not be possible, but it is happening right now, in 2026. And the strangest part of this whole story is that the technology that made it possible was not some brand new invention. It was an old idea nobody in the trucking world had bothered to take seriously. Stick around, because by the end of this video, you will understand exactly how the dirtiest, heaviest corner of the transportation industry flipped almost overnight. If you are finding this interesting so far, hit like. It genuinely helps this channel keep making videos like this one. And subscribe so you do not miss what is coming, because the story does not stop at the engine. It goes all the way to the driver's seat. The old problem with diesel. Diesel engines have powered heavy trucking since the middle of the last century, and there was always a very good reason for that. Diesel is powerful, it is reliable, and you can refuel it in 5 minutes at almost any truck stop on the planet. For decades, nothing else came close to matching that combination for hauling heavy loads over long distances. But diesel has costs that nobody likes to put on the brochure. Fuel prices swing wildly depending on global oil markets, and a trucking company has almost no control over that. Diesel engines are mechanically complicated, packed full of moving parts like transmissions, fuel injectors, and exhaust systems that constantly need maintenance and constantly break down. And then there is the emissions problem. Heavy trucks make up a small fraction of the vehicles on the road, but they are responsible for a wildly disproportionate share of transportation emissions, because every single one of them burns fuel constantly, all day, every day, hauling multiple tons of cargo. For a long time, this felt like an unavoidable trade-off. You either accepted the pollution and the maintenance headaches, or you gave up the power and reliability that made diesel trucks useful in the first place. There was no real third option. That is, until an old idea that the trucking industry had already dismissed once got a second look. The solution everyone dismissed. Electric trucks are not actually a new idea. Engineers have talked about them for years. But for most of that time, the concept was treated almost like a joke inside the heavy trucking industry. On paper, it sounds appealing. No engine, no exhaust, lower running costs. But anyone who actually worked with heavy freight knew the obvious problems. Batteries are heavy. And heavy trucks already spend their entire existence fighting against weight limits. Batteries take hours to charge, and a truck sitting still for hours is a truck earning zero money for its owner. And heavy trucking often happens in brutal environments. Blazing hot deserts, freezing mountain passes, thin air at high altitude, conditions that put enormous stress on battery performance. Because of all this, electric trucks got a reputation similar to a toy. Fine for a delivery van driving 20 minutes around a city. Completely unrealistic for a truck hauling 40 tons across a mountain range or through a mining pit at over 5,000 meters above sea level. For years, that reputation stuck, and most of the industry stopped seriously considering electric trucks as anything more than a nice idea for the distant future. Why the industry said no for years. To understand why electric heavy trucks stayed stuck on the sidelines for so long, you need to understand 4 problems stacked directly on top of each other. First, the weight problem. Cramming enough battery capacity into a truck to match diesel range meant adding so much weight that it started eating directly into how much actual cargo the truck was legally allowed to carry, which defeats the entire purpose of the vehicle. A truck that cannot carry a full load is not a truck anyone wants to buy, no matter how clean it runs. Second, the charging problem. Even fast chargers took far too long compared to a 5-minute diesel fill-up, and in an industry where time is quite literally money, hours of downtime was simply not acceptable. A parked truck earns nothing, and a fleet of parked trucks waiting to charge can bankrupt a logistics company faster than any fuel bill ever could. Third, the extreme condition problem. Real mining and freight operations do not happen in mild, comfortable weather. Some of China's largest mining sites sit in high-altitude regions of Xinjiang, with huge swings between day and night temperatures that punish battery systems. Fourth, the cost problem. At industrial scale, the battery packs needed to move this kind of weight were shockingly expensive compared to a proven diesel engine that had been refined for 100 years. Put those 4 problems together, and you get an industry that looked at electric heavy trucks and said, quietly but firmly, not yet. That verdict held for years. Then one company hit this wall so hard that instead of giving up, they built their own way around it. The idea that changed everything. The breakthrough that actually solved this problem was not a brand new battery chemistry discovered in a secret lab somewhere. It was something much simpler and much smarter. A complete rethink of how a truck gets its power in the first place. Instead of plugging a truck in and waiting for hours, what if you just swapped the entire battery out for a fresh one? The same way you would swap a propane tank on a gas grill. That idea is exactly what solved the downtime problem that had haunted electric trucking for years. Xinjiang Mining, one of the largest mining operations in the world, ran into this exact wall at its Wooligan zinc mine in Xinjiang. They needed an ultra-heavy electric haul truck that could survive the mine's brutal high-altitude conditions, and nothing on the market could do the job. So instead of waiting for someone else to solve it, they partnered with a company called Longking and built their own truck from scratch. The result was the LK220E, a 140-ton battery electric haul truck fitted with a massive 770 kilowatt-hour battery pack. The largest swappable battery ever used in a haul truck of this kind. And here is the number that changes everything. Swapping that giant battery out for a fresh one takes about 4 minutes. 4 minutes compared to hours of charging. That single design decision took the industry's biggest objection and simply erased it. It did not require inventing a battery that charges instantly. It just required admitting that charging was the wrong question to be asking in the first place. Battery technology company CATL has pushed this concept even further, developing swappable battery systems specifically built for commercial trucks, letting fleets exchange power the same way they would refuel with diesel, at dedicated swap stations built directly into logistics routes. And because companies like Xdol and Huigong manufacture their own battery cells, control systems, and electric motors in-house, they were able to design entire truck systems built specifically around trucking needs, instead of just adapting technology originally built for passenger cars. That vertical control over every component is exactly what let them move fast enough to actually ship a working product instead of just a promising prototype. From lab curiosity to national policy, solving the technical problem is only half the story. The other half is what happens when a government decides to push an entire industry forward at once. China's rapid adoption of electric heavy trucks did not happen by accident. New energy vehicle purchase incentives and trade-in subsidies made switching financially attractive for trucking companies. And the anticipation of new taxes on electric commercial vehicles arriving in 2026 pulled a wave of demand forward into the final months of 2025, which is a big part of why December's sales numbers spiked so dramatically. But this is not just a short-term subsidy bump. The market has genuinely matured. The 5 largest manufacturers of zero-emission heavy trucks in China, companies like XCMG, Seni, Fa, Shackman, and Yutong, now control 61% of that market, a concentration level that mirrors how mature the traditional diesel truck market already is. That is an important signal. It means this is not a scattered collection of experimental startups anymore. It is a real, structured industry with dominant players, supply chains, and manufacturing scale behind it. The same kind of transition that happens when a new technology stops being a curiosity and becomes the new normal. Once an industry reaches that point, it tends to keep accelerating on its own, because suppliers, repair networks, and financing all start building around it too. Real trucks, real mines, real scale. Numbers on a slide are one thing. Watching this actually work in the harshest environments on the planet is another. At Xinjiang's Wulajian mine, 290 of these 140-ton electric haul trucks are already running, and they now handle more than 80% of the entire mine's transportation. The economics behind that shift are hard to argue with. The energy cost per ton kilometer for these electric trucks comes out to roughly 0.177 yuan, compared to as high as 0.68 yuan for a diesel-powered equivalent, which is close to a 4-fold difference in fuel and energy costs alone. At Xinjiang's Zhejiang copper mine, the company has gone even further, deploying battery electric trucks fitted with autonomous driving systems, operating at a punishing altitude of 5,300 meters. Conditions that would be brutal for a human-driven diesel truck, let alone an experimental electric one. And the disruption does not stop at removing the diesel engine. It is now coming for the driver's seat too. A company called Cargobot, a spin-off from the ride-sharing giant Didi, has already put autonomous heavy trucks into real commercial use across China, and those trucks have already crossed 35 million kilometers of cumulative fully driverless operation. Their system uses what they call a 1+N platoon, where a single human-driven truck leads a convoy of up to 6 fully autonomous trucks following behind it, with the human handling only the messy, unpredictable situations like a chaotic toll booth, while the machines handle the long, repetitive highway stretches on their own. Diesel did not just lose on cost. It is now losing the steering wheel entirely, and it is losing it faster than almost anyone in the industry predicted even 2 years ago. What started as a single mine's engineering problem in a remote corner of Xinjiang has turned into a template other mining and logistics companies across the country are now racing to copy. The honest catch. As exciting as all of this sounds, it is worth being honest about what is still unresolved. Manufacturing enormous battery packs at this scale still carries its own environmental cost. From mining the raw minerals to producing the cells themselves. And that footprint does not disappear just because the truck itself runs clean on the road. The battery swapping infrastructure that made all of this possible is heavily concentrated inside China right now, built through years of coordinated investment between mining companies, battery manufacturers, and truck makers. That kind of infrastructure is not something another country can simply copy overnight without similar levels of investment and coordination. The upfront cost of building swap stations and manufacturing these massive battery packs remains enormous, even if the long-term operating costs end up being dramatically lower. And while these trucks have proven themselves at extreme altitude, years of real-world data across every possible climate, from Arctic cold to tropical humidity, are still being gathered. Diesel still dominates the vast majority of trucks working around the world today. What is happening in China is a rapid, accelerating shift, not a finished revolution, and the gap between what has been proven at one mine in Xinjiang and what would need to happen to replace diesel trucking globally is still enormous. Step back far enough, and this story stops being about trucks entirely. It becomes a preview of what happens to any energy-intensive, fixed-route industry once someone finally solves the downtime problem standing in its way. The battery chemistry existed for years before this breakthrough. What actually changed was the willingness to redesign the entire system around swapping instead of charging, and to back that redesign with national-scale policy and investments. The country that solves the infrastructure and logistics side of a problem like this, not just the raw technology, ends up controlling the next chapter of global freight. If this video changed the way you think about the trucks driving past you on the highway, smash that like button. It really helps this channel keep going. Subscribe and turn on notifications so you do not miss the next story like this one. And let me know in the comments, if China solves fully autonomous, battery-swapping trucking before most of the world even finishes switching to electric cars, what happens to the millions of people whose entire job is sitting behind that wheel?